Here we have a force in one-dimension problem that requires a little bit more thinking when we're dealing with it. So I'm going to walk you through step by step my thought process on solving problems like this. Okay. So the first thing we do is obviously we read the question and we're going to write down all the information that we know so we can see what we have, and based on that information we can point ourselves in the right direction. Okay. So we have a car with a mass of 1,400 kilograms. So I'm going to write that down. Mass is 1,400 kilograms. Okay. The car slows down from 30 meters per second to 20 meters per second. So I have an initial velocity of 30 meters per second. And I have a final velocity of 20 meters per second. Right, this all happens when the driver sees a sign for reduced speed limit 400 meters ahead. Okay. There is an air resistance of 1,000 newtons. Okay, so I'm going to write some displacement of 400 meters. I don't know what it's for yet, but I'm going to write down that I have displacement of 400 meters. And coming up to my diagram, I'm going to draw in my air resistance, which is 1,000 newtons. Right? I'm setting the direction as the direction the car is traveling. Air resistance is working against, so this will be a negative 1,000 newtons of force. The question asks, determine whether the driver needs to provide a braking force or just reduce the amount of driving force exerted, and find the size of this force. So a driving force and a braking force, these are forces that act in opposite directions. And what this question is basically saying is, do we need to just reduce the driving force? In other words, apply less of a force in this direction. Or do we need to provide a braking force? In other words, does the force need to be in that direction? Okay, so we don't even know the direction of the force. It could be either way. So the way I would approach this question is to say, well, let's just assume, let's make an assumption that the car can reduce its speed in this 400 meters and determine what kind of net force we need to have in order for this to happen. Okay, so we're going to make the assumption that this can happen and see what results. Now, the nice thing is that braking force and driving force happen in opposite directions. And so if we get a positive force, we know that it'll be just a reduce in driving force. And if we get a negative force, well, then we know that it had to be a braking force. So this is an unknown. We don't know what it is yet. We know that depending on the sign, it will point in a different direction. Because I don't know the direction yet, I'm just going to say that this force is force X. Now, we need to work out a net force, which means we need mass and acceleration. We don't have acceleration, so let's work out our acceleration first. We've got initial velocity, we've got final velocity, we've got displacement, and we want to work acceleration. So we will use v squared equal to u squared minus 2as. From here, we just put the information that we know into the equation. 20 squared equal to 30 squared plus 2a is what we're trying to work out, and displacement of 400 meters. Okay, so we're making the assumption that the car has reduced its speed in time, and we want to determine based on that what the force would be. Okay, this is going to give me an acceleration of minus 500 over 8. So this will be minus 0.6 meters per second squared. Okay, and that makes sense based on the direction we have called positive. In order to reduce speed, there must be some deceleration. Okay, so now we have our acceleration amount. Right, to determine the force, we know that the force is equal to mass times acceleration, and we know that this force here is the net force, okay, or the resultant force. And we know that the resultant force in our case is just the sum of all the forces, right? And in our case, we have the minus 1,000 Newton air resistance, and we have this force X, which we don't know what it is yet, right? We know that these two forces are equal to the mass times acceleration of the vehicle. So this is 1,400 multiplied by minus 0.6. Right. I just had a brainwave that 5/8 is 6.25, not 0.6. Right. And this is meters per second squared. Okay. This is going to give me minus 1,000 newtons plus x equal to, well, we can punch into our calculators, 1,400 times 0.62, well, negative 0.625, and that's going to give me minus 875 newtons. Right, to solve for x, we're going to move the 1,000 over to the other side, and I'm going to get x equal to 125 newtons. Okay. So the force required to bring the car to the correct speed, right? The net resultant force requires us to apply a result or a driving force of 125 newtons. And so in this case, the driver would just need to reduce the driving force exerted. So we can finish the equation by saying reduce the driving force to 125 newtons.